In this video, the learner will apply and use the laws of deductive reasoning. An example of deductive reasoning in the real world is Sudoku puzzles. Every Sudoku puzzle has a unique solution that can be reached logically. In each box, there's the digits 1 through 9. In each row and each column also contains the digits 1 through 9. You use process of elimination and logical thinking to figure out where exactly these numbers are going to go. So for example, in this row here, we have all the digits in this row except for a 3 and a 5. So I know these two blank spaces need to either contain a 3 or a 5. Then I also notice that I have a 3 in that column. Therefore, I know a 3 cannot go in this space. That must be my 5. And in this space must be my 3. So I logically reach those conclusions using that given information in that puzzle. Remember that inductive reasoning uses patterns in very specific cases to generalize a conclusion and to make a conjecture. In deductive reasoning, we're going to use facts, definitions, accepted properties, and laws of logic to form a logical argument or reach a conclusion. So we're going to kind of compare and contrast these and use deductive reasoning today. We have two laws of logic that we will use with deductive reasoning. First is the law of detachment. If the hypothesis of a true conditional statement is true, then the conclusion is also true. So here's an example. If P implies Q is true, so if that whole conditional statement is true, then we can reach that conclusion. So that logical argument would consider this being our given information, then we can conclude Q. Think about this as breaking the P and the Q apart. Notice the law of detachment tells us that. We're detaching P from Q. So Q would be our logical conclusion. Second is the law of syllogism. This considers three statements. We have if the hypothesis P, then conclusion Q. So that is our P implies Q statement. If hypothesis Q, then conclusion R. This is Q implies R. Because we have P implies Q and Q implies R, a reasonable conclusion using the law of syllogism is that P implies R. So you can kind of think about this as a middleman. Because we're using the conclusion here as the hypothesis here, we can get rid of the middleman and say P implies R. So if both of those statements are true, then P implies R is a true statement and a valid conclusion. Okay, here we're going to use the law of detachment to make a valid conclusion in the true situation. So for A, given that we have two segments that have the same length, they will be congruent. So we have the statement, if P, then Q. Then we also know that the measure of segment BC equals the measure of XY. That tells us we have two segments that have the same length. Therefore, according to the law of detachment, we would know that segment BC is congruent to segment XY. We're following that if-then statement to make that conclusion about that specific case. I want you guys to do part B by yourself. Part C here, if a car is out of gas, then it will not start. Emma's car is out of gas. We're using this generalized statement, if a car is out of gas, then it will not start. And we're given a very specific case that goes with the hypothesis of that P implies Q statement. So given that Emma's car is out of gas, we know it must not start. So a valid conclusion based on the law of detachment is Emma's car will not start. In this example, we're going to consider the situation and determine if a valid conclusion can be made. So the situation is, if a primate is an ape, then it does not have a tail. Coco is a primate that doesn't have a tail. So we're given this P implies Q statement. If a primate is an ape, it does not have a tail. That is a true statement. And we're given that Coco is a primate and she doesn't have a tail. You might conclude that Coco is an ape. However, that would be a false conclusion for this situation. Notice that Coco is an ape is part of the hypothesis of our conditional statement. Our law of detachment says if P implies Q, then we can conclude something about our conclusion Q, not about our hypothesis. So make sure when you're looking at your law of detachment, notice we're given if P then Q, and we're given something about Q. So here, no valid conclusion can be made. A valid conclusion cannot be determined. Here we're going to try and use the law of syllogism. If you get a job, then you will earn money. If you earn money, then you will buy a car. Remember, the law of syllogism is if P implies Q, Q implies R, then we can get rid of the middleman and say P implies R. So this first conditional is P implies Q, and the second statement is Q implies R. Notice the Q of the first statement is the Q of the second statement. So you will earn money, you earn money. So we can get rid of that middleman, and our valid conclusion can be if you get a job, then you will buy a car. So notice using the law of syllogism gets rid of that middleman and then combines into one conditional statement. Right, for inductive reasoning and deductive reasoning, we're going to compare and contrast what we've done for both. So inductive reasoning is based on observations, past experience, patterns, and very specific cases to reach a conclusion. We've noticed in some of our arguments that it doesn't always lead to a valid conjecture or a true conjecture. Sometimes it can give us a false conjecture. In deductive reasoning, it's based on facts, definitions, postulates, properties, and theorems. It moves from a general observation to a specific result. Notice using our laws of logic, we were given a general conditional statement and looked at a very specific situation. We can use it to prove conjectures, and it always leads to a valid conclusion provided that our assumptions are true. So as long as the premises that we're dealing with are valid, then our conclusion should be valid. So these are kind of the processes for each one. Looking at inductive reasoning, we find a pattern, make a conjecture, and either verify or modify if we were able to find a counterexample. Inductive reasoning only works from more specific observations to a broader generalization. Deductive reasoning uses facts, definitions, and accepted properties to reach that logical argument using those laws of logic. So deductive reasoning is using very generalized properties and definitions to reach a very specific result. So we have examples of inductive and deductive reasoning. This example of deductive reasoning, Tom knows that if he misses practice the day before the game, then he will not be a starting player. Tom misses practice on Tuesday, therefore he won't start on the game on Wednesday. So this is a very generalized statement. If he misses any practice, he knows he won't be a starting player in the next game. And we have then a very specific case. He missed practice on Tuesday. It's very specific. So our conclusion is therefore a very specific conclusion based on the case that we're dealing with. He will not be able to start on the game on Wednesday. An example of inductive reasoning. Mia came to class late this morning. It's a very specific observation. Another observation, Mia's hair was uncombed. From prior experience, Mia is very fussy about her hair. The conclusion is that Mia overslept. That may or may not be true. So we have to be careful about inductive reasoning. It may or may not lead to a valid conclusion. Notice these are very specific observations, and we're making a generalization based on those observations. In these examples, I want you to determine whether inductive or deductive reasoning was used. Go ahead and have these all in your notes.